A very good morning to my fellow student. Welcome back to our lesson. So today we are going to we will go through the sound wave, the topic of sound wave, and the subtopic of the bits. So the aim of the study today is to study and understand the level of intensity of sound. Second aim is to study how bits are formed. For the lesson objective, in this lesson, students use dB decibel to define the level of intensity of sound. Calculate the level of intensity at a given distance from a point source and explain the formation of bits by the principle of superposition. Use the formula for bit frequency where F equal to F1 minus F2. Now we are going to the lesson. Okay. Okay. Introduction. A guitarist turning a guitar often relies on listening for beats to help judge when two notes are of exactly the same frequency. When two notes of slightly different frequency are played together, the sound gets louder and then quiet periodically. That's when loud and soft. This vibration in intensity are called beats. When the notes are of exactly the same frequency of beat are not heard, this tells the guitarist that the strings are tuned. So in this lesson, we'll learn how to use the decibel to define the level of intensity, calculate the level of intensity, and explain the formation of the beats, where the formula for the beats is F equal to F1 minus F2. Ladies and gentlemen, for the sounds produced, let's say 198 Hertz. How about 199 Hertz? 200 Hertz. Again with 200 Hertz. Symbol of 200, they are same, right? What will happen if we can play together? 200 and 200. If 189, 98 and 99, we notice that they are different. If 198 with 200, okay, slightly bigger difference. We hear that once they are two different frequencies, slightly different frequency, we notice that the sound stop, or there will be no amplitude or silent, okay, for a very short moment. We call that these are the beat. Okay, I think that everybody have the experience. Do you have the experience speak or shout in front of a turning fan? So when we shout in front of the turning fan, we notice that our sound are slightly different. The difference is because our sound stop momentarily, okay, in very short moment. That's because this phenomena, we call that is the beat. Okay, the phenomena beat of the sound. Okay, consider we have two wave, okay, two coherent wave, where the superposition produced will be the constructive superposition. How about the bit period? In this, we said that the bit period is infinity, and the bit frequency will be 0, because the bit period t is equal to 1 over f. Frequency, the difference, the frequency exactly, both with the same frequency. That means that the bit is the difference between the two frequency. The bits, the difference is equal to 0 hertz or 0, okay, 0 frequency. So that means that 1 over 0 become period. Period is 1 over f. So 1 over 0, that means that period is equal to infinity. Now, what are the difference if okay, let's say I make it become 2 and 1. The green color with 2 hertz, the blue color with 1 hertz. We notice that the superposition graph will be different. So this means that the bit frequency difference, 2 minus 1 is equal to 1. Bit frequency 1 over 1 is equal to 1 bit period. If, okay, let's say they are slightly different. Two, the difference, the bit is the difference of the frequency. 2 minus 0.66, that means 1.33. Okay, 1.33333. So from here, by period is equal to 1 over f, 1 over 1 over 1.33, we get that the bit period is 0.75 second. Okay. Next, the derivation of bit frequency by principle of superposition. Let's Y1 represent the oscillation with frequency F1, and Y2 represent the oscillation with the frequency F2, where the F1 is greater than F2. Frequency 1 is greater than frequency 2. Then the Y1 and Y2 can be written as Y1 equal to A sin 2 pi F1t, and Y2 is equal to A sin 2 pi F2t. From the principle of superposition, the resultant oscillation is given by Y equal to Y1 plus Y2, where Y is equal to A sin 2 pi F1t plus A sin 2 pi F2t is equal to 2A cos 2 pi F1t minus 2 pi F2t divided by 2, and sin 2 pi F1t plus 2 pi F2t all divided by 2. As a result, it becomes 2a cos pi f1 minus f2t sin pi f1 plus f2t. The terms of 2a cos pi f1 minus f2t represent the resultant amplitude. For intensity to be maximum, the resultant amplitude should be maximum. This will occur when the magnitude of cos pi f1 minus f2 t equal to 1. A big maximum will occur as pi f1 minus f2 t, where t equal to 0, okay, where is equal to 0, okay, pi, 2 pi, 3 pi, okay, 4 pi, 6 pi, and so on. This will happen when t1 equal to 0, t2 equal to 1 over f1 minus f2, t3 equal to 2 over f1 minus f2, and t4 equal to 3 over f1 minus f2, and so on. The time interval between the successive maxima is therefore given by t equal to t2 minus t1 equal to 1 over f1 minus f2. Therefore, the bit frequency is given by f equal to 1 over t equal to f1 minus f2. So this means that the bit frequency is f1 minus f2. The difference in the two frequency of the sound. As a conclusion, when two notes which are slightly different in frequency are sounded simultaneously, the resultant intensity will vary from maximum to minimum periodically. The phenomena is known as bit. Bit occur because the phase difference between the two sounds varies with time. At the moment when they are in phase, constructive interference occur, and at the moment when they are out of phase, destructive interference occur. The bit frequency equal to the difference between the frequency of the two sounds, where the resultant frequency or with the bit frequency is equal to f1 minus f2. Okay, so look at the animation. The worker is wearing the ear protector once an aeroplane is approached to him. Why? It's because the sound from the airplane, from the jet, is very, very, very loud. And the sound considered with a very high pressure. The sound considered maybe destroy our hearing ability. So once we hear the sound or the very, very loud sound, our eardrums consider will vibrate with the same frequency of the sound. If the amplitude is very loud, that means that this will cause our eardrum to vibrate with greater amplitude. And this may cause the damage of hearing to us. Ladies and gentlemen, let's make sure the sound. With a very far distance, consider we can't hear the sound. Nearer a bit, we can measure the sound. What will happen if the distance between the mic and the music are nearer? Notice that or not, the intensity of sound reduce and when the distance is further. And the amplitude of the sound also become smaller. So, ladies and gentlemen, a decibel meter is used to measure the loudness of the sound. For the threshold of hearing, mosquito flying is almost 0 decibel. When somebody whisper, okay, so this means the sound of intensity is around 10 decibel. In normal conversation, okay, the distance of 1 meter, or CRO, the communication distance, okay, the safe distance 1 meter is around 65 decibel. Train passing by, the sound is around 80 decibel. Live rock concert is around 120 decibel. And the sound of explosion consider is around 130, for example. Even if the decibel increase, that means that the loudness of the sound will be increased. First, calculate the intensity using the intensity. So intensity of the sound, I equal to P over A, pressure over the area. So from here, let's say the pressure is 5. Okay, for example, is 5. So we calculate the distance, okay, with the radius of 5 cm, 5 meter as well. So we get that example is 1.59 times 10 to the power 2, okay, watt per meter square. From this value, we calculate the intensity level. First, we must calculate the intensity first. Okay, so intensity level, this means that, okay, in the decibel. So we use 10 log I over, okay, 1 times 10 the power negative 12. That's a constant. Okay, so as a result, we get that for this sound with 1.59 times 10 to the power negative 2 watt per meter square, the intensity level is 102 decibel. And if we repeat by using the power of 50 watt, just now power is 5 watt, yeah? Now 10 times 50 watt with the same, okay, same area. So we get that is 1.59 times 10 to the power negative 1. Okay, so this means that the intensity level is 112 decibel. So this means that the intensity for both is 112 decibel, where the increase in the intensity level between the first example and the second example, 102 decibel to 112 decibel, that means the increase in 10 level of intensity. That means 10 decibel. Okay, so these are the example of the formula, okay, for the calculation. So as a conclusion, the intensity level is defined as beta equal to 10 log I over I naught, intensity of sound over The I naught is the threshold intensity of sound, where when we calculate, the intensity level is measured in the unit of decibel dB. Ladies and gentlemen, this is the question for the worksheet for the question 1. Question 2. And also the question 3. Question 4. Question 5. Question number 6. And also question number 7. For the lesson, for the question solution, this is the solution for question 1. Question 2. Question 3. Answer for question 4. Answer for question 5. Answer for question 6. And last, answer for question 7. Okay, that's all for today's lesson. Please solve all the questions. Please solve all the exercise. And see you again in the next lesson. Thank you very much and hope you enjoy my lesson. See you next lesson.